Welcome. Thank you all for coming to my final presentation night. This is a presentation over all the stuff I've done this year in ISM and all my accomplishments. All right, so to start off, does anyone know what these are? Thank you. Thank you, Olivia. All right, so these are engines, yes. Okay, so this engine is from the new 2015 F-150, and this is a C32 Assert engine from Holton Caterpillar. So just a little comparison. The dimensions on this are a length of 73.78 inches, a height of 53.9 inches, and a width of 68 inches, and a weight of 6,625 pounds. And then for the Ford engine, it's a length of 30 inches, a width of 27, and a height of 32, and only a weight of 650 pounds. So obviously this one is much larger, even though you can't tell from the picture. So this is a diesel engine. They're both diesel engines. This is a V8, and this provides about 385 horsepower, and this one will provide anywhere from about 1,200 to about 1,500 horsepower. This is used obviously in the Ford F-150, and this one's going to be used to power heavy machinery, any large kind of tractor, a lot of the dump trucks you'll see in like mining operations, the big old ones with the tires that are huge. Yeah, that. So as part of the ISM, we had to pick a quote to use and incorporate for our yearly goals and stuff. So my quote I chose is, "A dream doesn't become reality through magic. It takes sweat, determination, and hard work." And that's from Colin Powell. He is a former Secretary of Defense for the United States. And I chose this quote because it's very true, and nothing you want ever comes easy. You always have to work for it. You have to be determined to get it, and you have to be able to put in the work. So a little bit about me. I am a junior here at Frisco High School. I've been in Frisco since 2000. I'm 17 years old recently. And my mom, she is a fashion merchandiser for Seven for All Mankind. My dad is a CEO of a company called Grable Moving Services. It's a logistical company moving, whether it be residential house to house or large scale moving equipment for this company, that company. This is my sister. She is a 6th grader at Pioneer. She'll go to Pearson next year with that school being built. I'm in National Honor Society. I've played football for 9 years now, and I love the outdoors. Love it. Go there and never come back, and I'd be perfectly happy. All right, so the reason I chose mechanical engineering is a few things. First thing is my uncle. He had a large influence on me in my early years growing up. He always had me outside doing something, fixing this pipe, fixing this wire, learning how to do this, changing oil, changing a tire, changing anything, working with engines, usually really hands-on experiences. So that really encouraged me to, advance myself in this field and really figure out what it's all about. I also chose it because of all the free will that you can have when it comes to it, being able to explore your interests and not having any boundaries and no limits, and always being able to create something new, not having to worry about something that if it hasn't been developed, you can go and develop it yourself, and just the free will that comes with it. I also chose it because it's used worldwide. There's not one country in the world that does not have a mechanical engineer somewhere in there. So that's a lot of job opportunities, a lot of diverse experiences that you can have, and a lot of different places you can work. So this is a little video about what life would be without some kind of engineer. All right, Coach Goff, that's good. So obviously we can all throw something together and hope it works. We can all, get together a project last minute, put it on a poster and hope it all stays, but who really knows if that glue's going to hold, if that tape's going to support it, or if the paper's going to hold together, or if it's all just going to fall apart. And that's really what an engineer does. An engineer is someone who decides if this is going to be strong enough in order to support whatever it's going to be doing, whether it be a piece of paper, a tire, a desk, or anything really. So otherwise we would all fall off our chairs and into our backs onto the ground. So a few reasons I took ISM is because freshman year I had Coach Goff for team leadership, and she really encouraged me to take it because of all the experiences that she told me that it would be able to provide me with. And we had a student aide who was the senior class president that year. Her name was Jasmine, and she was in ISM. She always talked to us a lot about all the experiences she gained in that class and how much she was able to go and spread her wings, and how she was able to experience real life experiences while she was still in high school and still being able to be under that comfort of not having to actually have a full-time job in order to experience those. I also took it because I knew that it'd be able to help me make real-world connections and start off my journey in any career field, being able to gain knowledge with potential employers and being able to gain references and resources that I'll be able to call later on. I also took it because I knew it would give me a jump start, also from things I heard from other people who were in the class. It'd give me a jump start as far as being able to decide what I wanted to do in college, decide what I wanted to do, or help me decide what I wanted to do for a career and other things like that. So my ISM journey this year, as in my first year, we had 5 interviews, and I interviewed a few people that we'll talk about later. We took a class trip to the University of North Texas. That was really cool. I was able to sit in on 2 classes. One of them was a intro to material engineering, and that really talked a lot about how you had to be able to understand what kind of materials you could use to put together and how they would work together and if they'd hold together and would make a better product. We have to have weekly blogs. We post them every week, and it's about our journey throughout the year and what we accomplished that previous week, and that just helps you keep updated and let everyone know what you're doing. Research and research assessments. We had to conduct various assessments throughout the year, as far as we got to pick the article, being able to understand what was going on in the article, and had to write an assessment, not just resuscitate the information, but be able to analyze the document and determine how it is relevant to our study. The research showcase. We had the research showcase back before winter break, and we were able to showcase all our research that we'd done thus far, and being able to get it out and being able to show everyone how far we'd gotten in the year. We also had to do original work. That is almost a pre-product to what we did for our final product. We had to be able to select a mentor from one of those 5 interviews. We had to create a final product and final presentation, right, which y'all are here for. Thank you. So for my research, I focused a lot of my research on a lot of modern developments that were going on while I was in while I was in the class, the first semester when I was going out on interviews, so I could get a little more background knowledge as to what was currently happening in the field of mechanical engineering and just engineering in general. I found a lot of articles about the new developments, such as a new gas or a fuel tank for a NASA shuttle, so that would give it a longer lifespan, so it could stay in space longer, travel farther, and reduce weight because it'd be a lighter material. I also found an article over a new lock design, as in like shipping locks through canals and stuff like that, and to how it was it didn't really require much energy because it was mostly used the gravity and the weight of the water itself in order to control it. And I also conducted research over the career outlook for engineering field, and it's very good. A lot of people getting jobs in the engineering field, a lot of different opportunities in a lot of different companies. A lot of people are hiring right now because they know engineers have a good foundation of knowledge in all fields, really, because they have to have all fields of engineering, because they have to have knowledge in electrical engineering, mechanical engineering, really oil engineering, really just engineering in general. So my 5 interviews. My first interview was Coach Goff, can you zoom it out a bit? Just like scroll back. I don't know why it's so close. It wasn't like that before. Perfect. That's good. Thank you. So my first interview was with Mr. Jeffrey Johnston. He is the CEO of Zodiac Aerospace. And he really talked to me a lot about how synergy was the key of engineering, being able to understand how the product had to get from conception to completion, and how being able to understand the process that it took to get there really helped get the product out faster and more efficient. He also talked to me that it's really key in the field of engineering today to be able to deliver what the customer wants and not just put out a general product. He talked a lot about being able to understand what the customer wanted, put it into production, stay with it all the way through production while keeping in contact with the customer to make sure that's what they wanted. He also told me that it's important to have a various skill set because, as I said, mechanical engineering is a very diverse field, and it helps if you have a lot of good background knowledge. So my second interview was with Dr. Randall Burrell. He is a supplier manager for Raytheon. Thank you. He taught me a lot about being able to have an open mind, being able to listen to what other people are talking about, but also being able to form my own general ideas and being able to develop my own way of thinking about things and being able to take the next step in the engineering field myself. He also taught me that when I'm working on a project or I'm working on really anything in general, to be able to ask the next question before the problem arises itself so you can prevent that problem from happening. Whether it's asking, okay, what happens if this happens, so you can prevent the problem and design something that needs to take that place in order to prevent it from happening. He also told me to be very curious. He meant that by go out, spread your wings, experience different fields, get a diverse background, get a good foundation under you, good knowledge base, and things like that. He also told me that it's really important to be proactive, going along with asking the next question, being able to see the problem before it arises, and being able to get ahead of the problem and being able to stop it before it even starts. So my third interview was with Mr. Zach Story. He is a project manager for Holton Caterpillar. He told me that while I'm still young and going through college and getting into college, that it's important to me to be able to explore my various interests and make sure that engineering is really what I want to do. Because when you go to college, it's a lot of money you're going to waste if you decide to change your major. So explore my interests, get out there, try this, try that, try all that stuff, not just focus on engineering and be dead set on it. He said get a head start. He suggested that internships are good. ISM was good, he said, when he heard about it. Really just being able to get yourself out there, put yourself out there in the field, and just get to know people that are potential employers. Again, he said to have diverse opportunities and to explore various interests, and those go hand in hand, and just being able to put yourself out there and experience different things and being able to decide what you like. My fourth interview was with Miss Kate Short. She is also a project manager for Holton Caterpillar. She also suggested that I explore my interest in being able to decide, what I wanted to do and making sure that's what I wanted. She also said that internships are key. She said that growing up before she got into college, that she had a lot of internships with other companies, and that allowed her to be able to get a good base under her and being able to understand, really kind of what she wanted to do and how it would impact her life and being able to go on to college, as well as when she graduated college, having those internships that allowed her to go ahead and get a job. Create connections, same thing as far as internships go, being able to just put yourself out there, making connections with those people that are in that work field, and being able to introduce yourself, conduct a good conversation, and being able to just experience that and being able to put your name in their mind so they remember you. My last interview was with Mr. Randy White. He also works at Raytheon with Dr. O'Burrell. Coach Goff. Thank you. I don't know why it's zooming in like that. Didn't do that earlier. Okay, so he really when I asked him, why he did mechanical engineering, what did he like so much about it? He said that when he was in college, it really stood out to him as a great field to work in. He said there was a lot of different diverse opportunities that he was able to achieve and being able to get under himself, so that he could, go out there and be more successful in his own work. He said take advantage of any opportunity that I get. if an opportunity is put in front of me, don't just waste it, to make the most of it, do the best I can at it, and being able to, produce something out of it that you really are proud of and that you're not afraid to, take credit for. He suggested, or not suggested, he really pointed out to me that it's really important to make a lasting first impression, because most of the time you're going to that first interview, and if you don't make that good first impression, that can be the deciding factor whether that you're going to get the job or not, or whether someone else is going to get the job and you're just going to be left out there. So make a good lasting first impression, and just be able to put yourself out there, present yourself nicely, and make sure that everyone knows what you're really there for. So for my mentor selection, I chose Miss Kate Short. She is, like I said, a project manager at Holt and Caterpillar. She has a Bachelor of Science in Mechanical Engineering, and she's been with Holt and Caterpillar a little over 3 years. I chose her because she had the most passionate. She was the most passionate person out of all the people I interviewed. She really cared about her job, and she showed a lot of excitement about wanting to help me learn when I was just interviewing her, and that really stood out to me and made me want to choose her as my mentor. So for my mentorship, she's given me a lot of hands-on experiences. She's walked me out into the yard where they keep all the newly ordered parts of the engines, a lot of the generators, a lot of different testing things, being able to walk around the shop and watch people actually putting together the engines together, and just being able to understand and be able to see the actual process from start to finish, and being able to understand how that works. She's introduced me to multiple people at the company itself. She's introduced me to a lot of the people who actually work on the floor putting together all her projects. She's introduced me to her boss. She's introduced me to multiple other of her engineer friends who work on the same floor as her, doing the same job as her. She's also introduced me to the floor manager, who makes sure that everything on the floor is running smoothly, all the projects are going in and out with good speed, they're not getting behind, they're staying on track, and that everyone has the parts they need. I've also been able to sit in on a few presentations. A few companies have come in, given a presentation, this is why you should buy my products. They're trying to sell the product to the engineers, the project managers, to buy their accessories to put on the engine, such as exhaust systems, ventilation systems, radiators, stuff like that. So that's really been good for me, being able to sit in there and being able to understand the interactions between different fields of the sales, and then also the engineers having to work together in order to create a product for the customer. So from my original work with the suggestion of my mentor, I focused a lot on the different types of power that come from generators. So there's 3 types of power. There's prime power, there's continuous power, and there's standby and backup power. So prime power is going to be anything that you start up your own gas generator in your garage, and you plug in your weed whacker to it, or anything, your weed your blower, anything like that. So that's going to be prime power, or the big ones that's going to provide an instant source of power and an instant source of continuous power that's going to last as long as it has fuel. It's also portable. So continuous power, this is going to be something that is going to be running something constantly and consistently without ever having to stop. So these are going to be used a lot in excuse me, a lot in remote locations, such as oil fields or newly developed cities. Anything that really is going to need a substantial, consistent, substantial source of power, and it's going to be able to provide that because it's going to be constantly running. Standby and backup power, that's going to be something that you see at like your hospital, your backup generators, anything like that. Anything that's going to provide security, backup power in the event of a power failure. So you'll see these a lot at like businesses, hospitals, government buildings, etc. So the different aspects that go into developing these generators. So prime power, obviously, it has to be able to run consistently and provide a direct source of power, like I said. So the things that go into it is it has to have a really good ventilation system, because obviously it has to be able to keep running. It has to be able to be portable, so it has to be able to be small enough, but also be able to provide a given amount of power to whatever the customer needs. The continuous power, it's going to have to be able to run consistently and continuous, never having to stop for an extended amount of time. So obviously it's going to have certain things taken into it that are going to allow it to not have to be maintenanced constantly, and that allow it to just keep running and functioning. So there's a lot of different ways that you can clean them out, a lot of different variations that go into the radiators that cool them down, a lot of different factors that go into accounting for how it's going to be provided its fuel supply, how it's going to be producing power, and what kind of environment it's going to be in, as well as what it's going to need to support that environment. So standby and backup power generators are actually going to function a lot like prime power. They're going to be built a lot the same way, except they're not going to have to be running all the time. They're going to have a fuel supply that's going to last for 10 days, and then it's going to run out, and it's going to have to be either refueled, or it's going to have to be substantiated by some other supply while that one's being maintenance. These are usually found in multiple areas, or usually when you find a standby generator, there's multiple of them. There you go. So they're like that because if one fails, then obviously one has to pick up the slack, and that's usually not good, because usually the power ratings for those are not usually enough to. There's usually two of them, because the power rating has to be able to accommodate both of those. So you'll find a lot of standby power generators along with continuous power, because, like I said, they have to be able to run for a continuous amount of time, providing constant power. So if these do fail, then these are going to have to step in and take the place until they can get those back up and running. So for my final product, don't have any pictures, it's still in the making yet. So I did a bicycle generator with the help of my mentor. The goal of this was to be able to create a renewable source of power and to be able to display my knowledge of engineering that I've gained over the past year. Its goal is to create a cost-effective source of remote power that could possibly be used, if it's a cost-effective way, in a third world country in order to provide power to power such things as like small appliances or anything like that. So when I have it for final presentation night, I'm going to have it over here somewhere, and I'm going to have my sister write it, and I'm going to have it power a blender, and we're going to make smoothies for the rest of everyone, so y'all should come if you can. So yeah, it's going to be really cool. The main factors that went into being able to decide if I was going to make how I was going to make the final product and what I was going to need to put into it was a lot of research, being able to understand, what's it going to cost, how much power is it going to provide, is it really a good idea, or is it just going to be something that's going to spend up wasting a couple $100s on that's really not going to be useful that much, as whereas I could just go buy a battery that could provide the same amount of power, but it'd be a lot cheaper. So what I found is that it could potentially be a good source of power and a cheap source of power if you were able to find the parts in the right way. So being able to reuse parts such as the motor, being able to go to the scrapyard and rip off a motor from old car motor. I mean the alternator for a car, not the entire engine. So being able to just understand the different aspects that had to go into that, and that needed to factor in, and being able to understand those, and if it was going to be a cost-effective way or not. So the different parts of that, there's going to be the bike. It's going to have a drive belt similar to the one that you're going to have in your car. It's going to be attached to the back wheel. It's going to turn the motor, and then the motor is going to generate power through, just like a turbine would. It's going to power to recharge a battery, like a car battery. Then the battery is going to go to an inverter that's going to turn the direct power that comes from the bike and the battery into alternating current, which is anything like all these outlets. Those are alternating current, and it's a much safer source of power than a direct current. If you didn't know, most of the U.S. The U.S. is one of the only countries that actually has everything wired as an alternating current. A lot of places have direct current, which is why if you ever go to Europe, they give you a little thing to plug into the wall for your hair dryer. Girls, if you know that, it's because your hair dryer is wired as a alternating current, and there's plugs are a direct current, so it has to convert that. It's like this because the alternating current is safer and it can travel farther. It keeps it from just overheating really fast. The direct current will have a lot of problems if you're going to try and power a power station from Kansas to power California. The power is not going to be able to get there. It's going to lose a lot of power along the way due to various factors, whether the wire it's used, leakage, anything like that. So the battery is going to go to the inverter, and the inverter is going to change the power, and then you're going to be able to plug any kind of appliance with microwave, blender, obviously, lamp, anything like that, charge your computer into the inverter that will then provide you power to be able to support your computer or any power source. Thank you for coming. I really appreciate all of you coming tonight. It's been a lot. It's been a great year, and I really look forward to doing this next year. Are there any questions? No? All right. Fantastic.